Okay, this is the third part to this video about this transformer. I mapped the other two windings out that I was having a little trouble with earlier. I ended up having to crank the Variac up to 22 volts to get not enough there to work with. And then I calculated out the equation, the math determining what voltages the output would be. And what I determined was that those three tap transfer winding with the center tap, I had originally 2 volts in, I was getting 5 volts out. So that means about, if I cut 120 volts down to 2, that's 60. If I did that, multiply it by 5, I get 300, which would probably be one of the voltages for the vacuum tubes. And then basically between these other two sides of that tap, I was getting double that. That'd be 600 volts. I'm not quite sure what that would be for a tube. I suspect that was probably like a 300 volt on each side of that, and in the middle is ground. Would be my best guess, because it had like 4 or 5 tubes in it. So it may have been some way to share the load or something like that. And then I determined that the pins 6 and 11, which had a little bit more voltage before, when I put it up to 22 volts, I was getting about 1 volt out. So then that, I calculated out that it came out to about 5.45, 5.5 volts with a 120 volt input. And then I calculated out that the other one would be at about 0.8 volts, would be about 4.3 volts. And that was basically, this is basically just ratios. So I just did, I did 120 divided by 22. That tells me it's about 4.5. And I already knew that was 1 volt, so that's close there. This one I had to do a little bit more work. I had to take that number, then times it by 0.08. Because again, 0.8 volts out, that gives me about 4.5, 4.3, 4.5-ish. Usually for transformers, that's close enough, just so I can know what's going on with them. Then I have something to work with when I need to know exactly what I was working on. I'd have meters and stuff hooked up, and I'd probably have a regulator on it. And then this is unloaded too anyway, so it's going to be a little bit more. But that's kind of how I usually figure out transformer ratios. It's not the most pretty method, and it takes a little to get math and figuring out sometimes, but especially if you don't know what the windings are, this is probably about the safest. Because if you put 2 volts in a winding, you don't really know what it is. It's probably, odds are it's probably not going to hurt anything. If you put like 120 in the winding or something, that was like, if I put like 120 to one of these 5 volt windings, I could have thousands of volts up there. You don't want that, so you'd hurt yourself. You could catch things on fire. You could fry the transformer. You could fry the Variac trip breakers, whatever. And this seems to be the safest way I found to do this. You can do it sort of based on the ohms at the voltmeter when you check the windings. That gives me some idea, because the more windings you have, the more resistance it'll have. But it's still just it's pretty much just a coil wire. So unless you're passing AC through it, there's not really any not much resistance there until you get the AC in there and induction and everything. That's kind of why I use this method. And this is, and in the way you hook the transformer up, I have this thing I made. It's basically an old 16 gauge, 18 or 16 gauge cord. I stripped some, like 6 inches off it, put some insulated clips on it, and then I put a plastic thing around the hot lead. And just keep in mind, Variacs are non-isolated power supplies, so if you had this up to 120, you could get a shock off this. But that's not really, as long as you're careful with it, and you're not doing stupid stuff, that's pretty much the only thing you gotta keep in mind. This thing I only use with this Variac usually. Occasionally I use it with something else, but I'm always careful with it. Sometimes if I'm not even using it for a while, I'd put like a wire through the holes in the pins so nothing gets plugged into it, or it doesn't get plugged into anything. That's probably one of the more dangerous tools I've used. But I usually use it with the Variac, so what I'm working with is usually step down at least somewhat, probably at least a half or more. And I think that concludes this video. But pretty much all you need to do this is a Variac. Doesn't even need to be heavy duty. This is 70.5 amp, more than I probably need for this. Some kind of a cord with clip leads probably. Transformer to test with. A voltmeter. Leads. Clip lead for your meter. At least one lead would be nice. So then you can lock it down and you can move around the other lead. Calculator. Some paper and a pen. And if these don't have marks, you just gotta make a diagram for yourself so you know what's going on with it. Usually when I get a transformer, I do that, but for one of the first things, so then I don't keep something that's not working or useless to me. That's kind of conclusion to this transformer series.